This is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic MOS transistors non-ideal IV characteristics from the subject VLSI design. So here is the outline of this video. So we are starting with the transistor ideal IV characteristics review, and then we will be starting the different effects of the non-ideal MOS transistor characteristics. So here we are seeing in this slide the current equation for the three different regions of the MOS transistor in the ideal stage. So we will be having cutoff region, we will be having 0 as the IDS value, and in the linear region, that is non-saturation region, the IDS depends on the VDS, VGS and VT value, and in the saturation region, the IDS value, that is drain current, it depends on the VGS and VT value, where beta is a constant. So everything calculated, so the ID value is calculated in three different regions based on the condition, ideal condition. So here non-ideal represents, so practically if we are implementing the MOS transistor, we will be seeing different changes, so that is listed here starting with velocity saturation. So ideally we will be considering, so even when the electrical field increases, the velocity of the particular charge or carrier will be increasing linearly. So but in the non-ideal condition, if we are seeing this plot, so the if the electrical field increases from 0, so at the earlier stage the velocity also increasing, speed is increasing. So but if it is increasing more, so if the electrical field is increasing more, then the velocity goes to the saturation region, there is no increase in the velocity. So that is the non-ideal case. So next is channel length modulation. Due to the increase in the VDS value, so that is drain to source voltage value, so the depletion region will be created, so which reduces the channel size so that the flow of electrons will be reduced. So that is your channel length modulation. So here is the activity for this video. Count the number of times that the letter F appears in the following sentence. Okay, and then continuing the topic, non-ideal effects, so in which body effect is one part. So here the threshold voltage of the MOSFET increases if the voltage between the source and body increases. So if a number of transistors connected in a circuit, so only for few transistors the threshold voltage will vary, and for few transistors threshold voltage will remain constant. So in such case, so due to the difference in the threshold voltage, this effect is called as a body effect. And then subthreshold leakage. So here we are considering, so whenever the transistor goes, the input given to the transistors goes less than the threshold voltage, so there won't be any conducting part or transistor won't be on. So but it is only in ideal stage. Now when we are going for practically in non-ideal stage, so it will conduct micro level, it will start to conduct in a micro level. So this is very, very important, we need to consider for low power calculations. So it is high leakage leads to, so this and all leads to leakage, which leads to battery drains. So next one is mobility degradation. So ideally we are thinking that the electrons or any charges moves from source to drain in a straight line, so which is false. In practically it will scatters. In practically when VDS value or VGS value is increasing, the electrons moving from source to drain in the channel will moves in the form of scattering, so which will reduces the mobility. So next one is short channel effect. So this short channel effect is is reducing the channel. So when the technology increases with the reduction in the transistor size, the channel length also reduced, so that the flow of electrons will be reduced. So that is nothing but your short channel effect. Due to this, we will be drain voltage starts affecting the channel even near the source. So this creates an effect called drain induced barrier lowering effect. So this causes leakage current and poor switching behavior. So this and all affects the performance of the MOS transistor. So all this topic we have seen here under the non-ideal effects affects the performance, affects the effective performance of the MOS transistor, so which you need to consider while we are designing any circuit. So based on this topic, we are having an assessment part. So what is the primary reason for short channel effects in MOSFET? So reduced channel length. So what parameters is degraded due to the mobility degradation? So that is drain current. So what is the main factor that controls some threshold leakage current? Threshold voltage. So we can thank you for joining this video, everyone. We can join in the next video.